14 of Neetcode 150, trapping rainwater. This is a hard problem where we're gonna be given cubes or bars, however you want to call them, and we want to see how many cubes can be trapped. A good way to represent it is to see this as rocks or walls, and let's say that this is the floor on, and it is a rainy day. We want to see how many blocks of water can be trapped without floating away. So for example, here we cannot add a block of water because in the real world it will just it will not be contained within the walls. Okay, so this is how we are gonna solve the problem. We are gonna use a two-pointer technique, and we're first gonna set our left pointer to the index 0 and our right pointer to the last index. So this is our left pointer, this is our right pointer. And at first, we're also going to set our what we call a left max and a right max. Okay, you will see why in the example. So we will set our left max to that starting index, and we will set our right max to that starting index. And what we're gonna want to check is the left index or the right index the smallest? Here it is the right index. So we're gonna shift our right index by 1 to the left, right? So we're gonna put it here. And after this, we want to check if the right index that we are at is greater than the right max. Recall that our right max is just the last index as the current state of the problem. So yes, our right index now is greater than the right max. So we're gonna set our right max to that new right index. Okay. And the number of cubes of water that we're gonna add is basically the right max minus the right index. You can see now that the right max and the right index are both 2, so subtracting 2 by 2 is gonna equal 0. So we're just not gonna add any cube for this round. And we're gonna keep looping. So for this second loop, we're gonna see that now the left index is smaller than the right index. So we're gonna move our left index by 1, and we're gonna check if the left index is now greater than the left max. Well, our left index is now 0, and our left max is 1. So the answer is no. And we are gonna return basically the number of cubes of water that equals the left max minus the left index. So 1 minus 0. This is 1. Cool. So you can see physically the reason that we are trapping 1 cube of water here. Okay. So now we're gonna keep working through the loop, and we're gonna see that once more the left index is smaller than the right index. So we're gonna move our left index by 1. Okay, and we're gonna check if now the left index is greater than the left max, and the left index is 2, and the left max is 1. So yes, so we're gonna set our left max to this new left index, and we're gonna return left max minus left index, which is 0. Okay, I think you understood the concept. After this, we can see that we have both indexes with the same height, so it doesn't really matter which one you decide to move. Let's say we pick the right index to move. Okay, so if we move it by 1 to the left, put it here, we see that the right index is now smaller than the right max. So we're not gonna update the right max, but we're gonna return right max minus right index, which is 1. So we're gonna add 1 cube of water. Okay, so I think you understood the logic, right? So if I go a bit faster, we're gonna check now which index is the smallest. It is still the right index that is the smallest. So we're gonna move our right index by 1 to the left. We're gonna see that it is greater than our right max, so we are gonna update our right max. Cool. So our right max and our right index are not the same. So we're going to return 0. And after this, our left index is going to be smaller than our right max and our left index. So we're going to move our left index by 1. And we will end up adding another cube of water here, okay? So let's go ahead and try to implement this in Python. First thing, we want to see if the array that we are given is empty. Okay, so if not height, well, we want to return 0 because we basically have no walls to trap the water. And then we can start our algorithm. So we're going to set our left and right pointer. Our left pointer is going to be equal to 0, and our right pointer is going to be equal to the last index of the array. So height minus 1. All right. And for this first round, we want to set our left max and our right max equals basically to our height at the left index and our height at the right index. Cool. We have to keep track of the amount of water that we kept, so we can call maybe just water. All right, and first it starts at 0. So we want to loop until our left pointer is equal to our right pointer. So basically, why the left pointer is smaller than the right pointer after which we want to stop. We want to check if the left max or the right max is greater, right? So we will say if left max, for example, is smaller than the right max. Well, in this case, we want to move the left index by 1 to the right, so we'll increment it by 1, and we want to see if the left max, well, we want to set the left max to the maximum between the current left max and the height at the left index. Okay, and if the left max is equal to the right max, or the right max is smaller than the left max, right, we're going to put all these statements in the else. We're going to move our right index to the left by 1, and we want to set our right max to the maximum of the current right max and the height at the right index. Great. And I forgot one thing here. We want to add to the water, basically the left max minus the height, the left index. And we want to do the same thing here. So water is going to be equal to basically the right max minus the height at that right index. And we will allow that loop to go through every single index until the left pointer is equal to the right pointer, and after this we will be able to return our water confidently, and this is going to give us the amount of water that can be trapped inside the structure. So I forgot capital M. All right, did I forgot anything else? Max? No? Okay. So this is how we solve the problem 14 of Neetcode 150, trapping rainwater. This is a hard problem, but it can be solved in 19 lines of code. So if you understand the concepts of two pointers and you're efficient at it, it is really not that bad. So I hope you learned in this video, and I hope to see you in the next one.